Okay, let's start with syllabus. Actually, before the class, I uploaded the syllabus to the Blackboard. If you want to access the syllabus, here is the location. At this syllabus tab here, you may download this schedule from this tab. And I want to explain some important parts at this PowerPoint. Again, I'm Elif Deniz Yermenoğlu, if you have no idea about me. And my office hours are these times and my office address, my office number is 111. And then here is my mail address. If you want to access me, you can send me mail. Also, if you want to ask something at this office hours, if you want to arrange the time, if you want to ask something at face to face, actually, you should get an appointment by mailing before you come, at least 4 days before. And our class time and textbook list in here. Actually, you don't need to use any specific textbook in this class, but if you want, you may use any other extra source. As you know, we have so many online sources and also textbooks. If you want to use, you may, it's your choice, but there is no obligation to use any specific textbook. Class notes will be adequately enough for you. In here, we have two midterms, as you see, and the percentage values are stated, as you see. And then our final exam. If you don't take this final exam, you will get F, unfortunately. And here, actually, we have another constraint about final exam. As you see, final exam score must be at least 40. If you get any lower grade than this value, you will get F again. And other course rule is attendance rule. As you see, you should attend at least 70%, as you see. And we won't change anything about these constraints. In this part, you see this letter grade table, and we won't change anything at this table again. Okay. And important course rules. Actually, in the previous term, we struggled with so many student-based problems. Because of this reason, actually, I want to show some specific course rules to you. Initially, the first one is students who are absent due to a health problem. You should give your health report to me, as you see, both by email and as a printout. Okay, and we have a due time for this reason, for this case, as you see, within 7 days. 7 days, you should submit this health report to me. Okay, and also, as you see, these reports sent later will be considered invalid in here. And students who retake the course don't have to attend the course. So we have an attendance condition in here. If you took this course before and if you didn't fail because of your attendance problem, you don't need to attend again. Actually, we are not applying this condition which is related with your attendance structure. And if you have a transcript, you should, actually you all have some transcripts, you can easily prove this structure to me, and you should give this report to me until this date, as you see. Okay, and then the student is responsible for following up on all elements related to course notes, documents, and absences. These following operations are your responsibility. You should check your current status in every week. Emails containing requests regarding attendance, letter grades, or passing grades at the end of term will absolutely not be answered. Okay? Please don't send any mail which contains these requests. Give me 5 more points, please. Okay? These kind of mails won't be answered. And also, materials to be used in the course will be added to the course page on the Blackboard. Blackboard platform is this platform, as you see, not to the A-Campus platform. In here, we will actually create our interaction by using this course page. I will add some announcements. I will add some maybe notifications in here. And also I will add your class notes at this class notes tabs for each week. It's hidden. Now you can access your first week's document. Okay. And also for each week, I will create a recording, as you see in this part. And how can you access these records? In this part, when you click on this virtual class part, you will see this class online tab, and then when you click on this, you will see this page. At this part, we have so many tabs, but the left part is this part, recordings. As you see, after each recording session, you will see recorded video in here, and also you can be able to download easily for each week's record in this part. And the other important parts and the crucial part is this announcement part. You should check this announcement part nearly every day, okay? Because sometimes I'm adding some announcements in here, but this mailing simultaneously can be a problem to your accounts. And please try to check this announcement parts every day. And also, is there any other thing for me? No. We have no projects, we have no quizzes. As you know, we have just 2 midterms and 1 final exam in this term. Let's go back to the class notes. And emails sent to faculty members outside of weekdays hours 9 and 5, as you see, will not be answered. Please try to send your mails in an appropriate times. Okay? For example, don't send any mail at weekends. Okay, at that time you cannot actually get a response. And in here we have a cheating rule. I don't want to explain this cheating rule because it bothers us. And also, if you have any action, any bad action, which includes this cheating structure, so you will get some serious consequences about that time. And let's dive into this course content. In this week, actually, we will see some basic concepts. And so we will see some programming languages, differences, and for example, what is programming, and also what is machine language, what is assembly language, what is high-level language. So we will try to understand these differences between them. And also, after all, in this term, actually, we will create some flowcharts. We will create some pseudocodes to solve some specific problems. And I will show the platform while we are creating our algorithm structures in this term. And introduction to algorithm design is related with our second week. As you see, we will start to create our algorithm structures. Then in our third week, we will try to create our flowcharts and pseudocode concepts. And another important topic is number systems. Number systems are so important thing in this programming world, actually, because we are playing some zeros and ones in this computer part, but generally we have some different number systems. For example, for base 4 or base 10, base 10 is so familiar with us, as you know, but base 16 can be complicated for you. And also base 8 can be a complex structure for you. So we will try to understand these different number systems at our fourth week. And then in this fifth week, algorithmic problems related to numbers. We will try to solve some algorithmic problems which are connected with these numerical structures. Then if we have some conditions in our problems, we will try to represent these conditions into our algorithms. Then we will see this loop structure. In some problems, actually, we need to construct some repetitive solutions. For example, if you have, for example, 10,000 students in your college or something in your school, if you want to send an email to all of these students, you don't want to do this operation one by one, right? Because it has a cost about timing. So at that time, you should create a practical usage. So at that time, we should use these loop structures. We will repeat the same operation by using just one loop. So we have a count, so which this count must be equal to our student number, right? So at that case, we will use these loop structures, but generally, representing this loop structure into these algorithms is so important for us again, because if you want to start to create any code, if you want to write a code, you'll need to create this algorithmic background initially. If you get any problem at this coding part, it must be related with your algorithmic background. This creation step, this algorithmic creation step is so important for us as a programmer. Okay, and yeah, actually, you may say, actually, I'm choosing this code first approach. Yes, it can be your choice, but at that case, you are accepting I can encounter any failure. So this solving can actually cause some other problems. Okay, and initially you should actually imagine some extra conditions. You should imagine some problems before you start the coding part. Okay. So, as a programmer, we need to create these algorithms. As you see, at this 8th week, we will have this fall semester break time. After this break time, we have, as you see, first midterm. And it means actually you will have a time to actually complete these missed parts in this part. And after this midterm, we will start to see arrays, and also we will see some basic data structures. In this programming area, actually, we should consider every criteria at the same time. So this memory criteria, this actually, for example, CPU speed, and also memory allocation. You should consider all of these things while you are programming. At that time, you will create a professional program. But if you don't consider these constraints, actually, you will be a bad programmer. Sorry about this, okay? Because of this reason, actually, we will learn these arrays and basic data structures. For example, now we are done with these arrays, and we allocated and we stored so many data into memory areas, and also we defined these data structures in an appropriate way. But I want to search and I want to find a specific value, a specific data into this memory area. How can we do this? By using this searching algorithms. We have so many different pre-written algorithms, actually created algorithms. We will try to apply, we will try to learn and understand these algorithms. And then, for example, you have so many unsorted data. So this unsorted data should be in a numerical data, as you can imagine. In here, sorting algorithms are sorting our unsorted arrays. And also, we should know what are these sorting algorithms, what are the benefits of these algorithms, and also we will compare the sorting algorithms. So advantages, disadvantages. So actually, these sorting algorithms is another important thing for us. And graph algorithms, Graph algorithms actually is a little bit complex than the other algorithms because now we are creating some tree-based structures. We are creating, for example, try to imagine we have some cities and also nodes or points, and we have so many different ways which are connecting these points. And then we are trying to, for example, we can try to find the shortest path between two different points, right? For example, we are calling these structures, these kind of problems, traveling salesman problems. And in here, actually, we are using this basic graph algorithms. After all of this background, we can easily understand this graph algorithms at the end of this term, okay? So, do you have any question? No? Okay. Actually, my advice in this class, please don't try to memorize everything. Try to understand everything. If you don't understand anything, don't be hesitate to ask this question, okay? Because as understanding new thing can be hard for you, and try to ask your each little question while we are explaining these structures to you, okay? And also generally, actually, we have 3 hours, as you know, for this class for each week. I'm generally doing in 2 parts these classes. I'm giving just one break time. After these 2 sessions, actually, if you have any question, you may stay and you may ask your question. But if you have no question, you may leave. And generally, we are actually doing our classes by this way. Okay. And in this week, we will have no more job, as you can imagine, because it's our just first week. I don't want to bother you from the first week. But this algorithm is so important thing for this department, for your future career, and this algorithm is everything. Okay, because this, as you know, this algorithm introduction to algorithm class is a prerequisite for another, for example, introduction to programming class. If you want to be a successful student for this one, you will fail and you won't get this C programming or introduction to programming class. So we have so many connected classes, as you know. So actually it shows the importance of this class. Okay. And let's start to talk about this. What is a computer? Actually, we all know what is a computer, and you know, we have so many definitions. As you know, we have so many different definitions for that. But please don't memorize everything. Just try to understand. Okay, I won't ask any definition question at exams. Okay, I will ask some actually imagination questions. We will create some flowcharts or algorithms to solve some specific problems in the exams. But in this part, we have some theoretical parts. Okay, you should understand, you should learn some background first. In here, a computer. What's a computer? A computer is what we have here. We have an input, we have an output. We, for example, by using this keyboard, by using this mouse, actually, we are entering some informations as well. It means we are giving this input to the computer, and after all of these operations, we get an output. It can be a document, it can be, for example, an language, it can be any other thing. It can be a report, PDF results. In here, actually, we are giving the input to our devices and we are aiming to get this out. In this part, we have central processing unit, the control unit, logical unit, and memory units. It means actually we have this part important because arithmetic, we all know what is important 2 plus 2 equals 4, right? It's an arithmetic operation. But what is a logical operation? So, for example, AND or XOR, you remember that, right? So we are comparing, for example, 1 and 1 equals 1, and 1 or 0 equals 0. So we are actually applying the memory operation at this here. And also, if you want to apply this addition operation, for example, 2 plus 2 equals 4. How can we do this? We should read this 2 value from somewhere, from our memory. Right? And then we want to write this result value to memory, right? So we need to play with this memory unit in this computer again. And then we have a controlling unit because, for example, quadro processors or we have better versions for this issue as well. It is related with the speed operation. Actually, this speed is everything for us because we want to create a actually fast program. We want to use less memory area. We should consider all of these constraints while we are creating our programs. In here, actually, if you want to apply some parallel programs at the same time, you should work with this control unit at the same time. For example, in this computer right now, I'm running this PowerPoint program, and at the background, at this browser, we are recording this screen area, right? We are running multiple things at the same time. So how can we order this process? We should use this process at the same time by using the control unit. Okay, so briefly, this computer definition is a central processing unit, memory unit, input units. I won't explain, but if you want, you may read. Hardware, the physical parts that we can see with the naked eye in the computer are called hardware. So hardware can be explained in 4 parts, as you see: central processing unit, CPU, memory unit, storage unit, and peripheral. And the other parts, other components can be called as hardware, as you all know. And what is software? Software, the out of this structures, actually we are calling other programs as software. Actually, operating system is a software, right? Word, Excel, Office programs, right? These are softwares. In this computer, calculator is a software. All of these other components, which are called as program, is in this software class. But we have some subclasses for them, as you see. System software is operating system software, such as Windows, Unix, Linux. And the program development software. I want to create a new calculator. It will be a smart calculator, maybe. I'm just throwing a random idea. And programming languages. I should use a programming language to create this program. For example, I want to speak, but I should use a language, right? So it can be in Turkish, it can be in English, it can be Spanish. So the language can be different, but the way of the solution is the same. Okay? In this class, we will create this way of the solution. Okay? This language will become after this logical background. These programming languages can be C, Java, Python, R. It can be C#, it can be any name. Application software. Microsoft Word, Excel, AutoCAD, it can be any other application software. And the product that emerges as a result of software development is called a program. In order for a problem to be solved by a computer, its algorithm must first be created. So, as the important is this. If you want to create a program which is so similar with Word, you want to create a new program. So at that time, you should start with a start point definition. At that time, you should create a path. And then, by using this design, by using this way, actually, you can easily create your codes. Otherwise, you will get so many errors at the time. Solving all these errors, we actually can take so many times for you. Okay, so, and also, for example, if you want to create a project, if you want to finish a project, and if you want to get a payment from this project, so the time is everything for you, right? So if you are extending this time as a developer, so you won't get any extra work in the future. So it's so obvious as you see. In this part, algorithm creation is a, I want to explain what is program, what is programming, what is programming language, and know your definition. So we will see some details. Actually, this devices actually works with just one and zeros, as you know. They are understanding the true or false. And is there any data or not? Actually, we have just two values for this one. But we should create a communication as a human, right? How can we actually tell some problems to our devices by using zeros and ones? Is it possible? No, we cannot write directly 0, 1, 0, 1, 1, 1, 1, 0, so it's impossible. Imagination of this order zeros and ones is impossible. So we in bodies, I guess, we have assembly language. Machine language is actually it's contains zeros and ones, and assembly language is similar with machine language, but not as difficult as machine language. They will be different. Procedural language, for example, C is a procedural language. But the other side of this generation, actually they are called as modern programming languages, such as Java, Python, C#, blah, blah, blah. In here, as you see, machine language and human. As human, actually, we use this five languages because coding can be easier than this machine language program, as you can imagine. So, remembering this print code can be easy for everyone. In here, this part, evaluation of programming language. Actually, I had a video to explain the history of the programming language. In the second part, I won't forget, I will show this video to you. And actually, programming history is so old. For example, Python is not a new language. C is not a new language. Programming and also artificial intelligence is not a new thing. It's just a popular definition nowadays. But these solutions, these concepts are not new things in our programming code. As you see, the modern computer in only programmers could only write software using assembly language. When I was a student just like you at my university, I saw this assembly language, and I'm sure you don't want to learn this assembly language as a student because it's so hard to understand, it's so hard to implement, and it's so hard to detect any problem. And also, for example, if you have 1,000 code lines, you should rewrite these code lines again if you have any error. So it's so actually time cost problem for an exam, as you can imagine. And here, I want to skip down. Hexadecimal code system. Assembler split machine code represents this part. C for run with ++01 as I said before, we have so many different languages, and we will pick the most appropriate one in future. Before this number system, I will go back, don't worry. I want to show this to you. We talked about machine code, right? It's computer's language. We cannot talk in the book in the language. So here is assembly code part. So assembly code is from 40s, as you know, and this coding part, yes, is much more understandable with machine code, but writing the structure can be hard for programmer. For example, this command called as load the value into the later, and then store this value at the memory area 30, and then load 5 to the accumulator, and then store this value to the memory 40 area. So actually, we can do this similar situation, similar process in a one line in a high-level language. But now we are writing this commands in some multiple separate lines. Okay. So, and also we should remember this memory locations address value at the same time as you see. So it can be hard. But is this assembly popular nowadays? Yes, we need to use this too. And actually solve any problem at this machine code level, we need to use this assembly language again. If you know assembly, you have to build R and you build person in this programming area. Actually, it means that. Okay? Because coding is so hard, understanding so hard, and also you have an ability to solve a specific low-level problem at the machine area. Okay? These high-level languages can take so long times solve any machine level problems. And I want to show this difference. You it's a better version of this assembly code. Actually, in this part, C language example, C code example, we won't write any code in this class, by the way. I'm explaining some details about programming area. In this part, we see this Java example. All of this code printing hello world to the output. It's so simple. And you see, in the C code, we have printf command. Printf command is so understandable command for us. It prints something to the output. So it prints this text to the output. That's all. And in this part, as you see, we are using the system of printline command to print something. But in this assembly part here, you should write so many things for just printing something at output. Okay? And let's go back. But after this number system, we will have a break. Common number system. In our number system speak, we will see this content detailing. Don't worry, I will just explain briefly. In here, we have some decimal binary, octal and hexadecimal number system. So decimal, we are so familiar. We have 10 number sign, some symbols to represent our number, right? So here are the higher numbers. Boundary volume for our part. And then is this decimal numerical system used by humans? Yes. Yes, right? Quite good, right? And is this used in computers? No. So it's the main problem for us. So we should learn this binary of non-hexadecimal number systems for this reason. In here, binary system, we have just two numbers and ordered 2. Used by autonomous? No. But used in computers? Widely. Commonly. Okay. In here, octal. In here, generally we are not using the number, but for this conversion operations, for some problems, we need to do this. Actually, for some computer vision problems, we need to use this kind of numerical. But at this middle area, for example, if you need to convert some numbers to the binary or decimal system, you should know this octal base numbers. And also hexadecimal used in computer actually yes, but it converts this hexadecimal number to binary number. Okay, so for example, hexadecimal number. How can we see this? Do you know color codes? color codes for web programming. You see any color code, hashtag, blah, blah, no. Okay, while we are creating our websites, we are using some color codes. In this part, color codes, just Google it, and HTML color codes here. For each color, we are using some specific color codes. And as you see here, when you select this code, you see this kind of HC493C. So we have some letters to represent our numbers. So F represents 15, and in here, as you see, for white, F, 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 F. So it's an hexadecimal representative structure, okay? So you may encounter, and also memory addressing operations. So we are storing our values at the memory, and we have some address numbers. So we will use these address numbers as a programmer. If you need, these address numbers will be shown as this hexadecimal based. Okay, so in this general numerical system world, we need to use, for example, used by humans can be no, used by computer can be no, used by programmers, all of them, yes. Okay. And let's have a break for about 10 minutes, and then we will continue. Çok bir imzanı alabiliriz. Bir dakika.
Diyorum ben geçen dönem kalmıştım da geçen sene.